So we're going to start off. I have online GDB, but if you wanted to use C++ shell, that's fine. Or if you want to use VS Code or Visual Studio, whatever editor you want, as long as I get the C++ code, then I'm good with that. And of course, it starts you out with a template, and all of them start out with different templates. But normally I go ahead and add the using namespace in here, std, so I don't have to do this std with everything. And of course, I don't want to print hello world to the screen, so we'll get rid of that. But I like to change my template a little bit, so I don't need that std on there. Okay. One of the things I wanted to talk about first were strings, because we didn't really focus on strings. And so one little exercise I wanted to do was working with strings. And so when I'm in here, okay, and you can go ahead and write your name at the top. And today is the 9th. And then this is just practice with strings. All right. Now, if I were to have a couple strings, I'm going to put some strings here in the main. So let's say we have a string. So one of the data types of string is anything that's text. And it doesn't have to be all letters. It can be numbers as well. Sometimes, you know, numbers can be strings as well. So if we were having a phone number, for example, that could be a string. Things that you're not doing in a mathematical equation would be strings. And so you might have like a zip code as a string, because normally we don't like add two zip codes together. We don't do any mathematical equations on zip codes or mathematical equations on phone numbers. So even though they're numbers, they can be strings. And we can do all kind of manipulation on strings, but we cannot do any type of mathematical operations on strings. So we can't add, multiply, subtract, or divide strings. So that's one limitation. So you have to decide if what you're doing, you're going to need to do a mathematical operation. So if we're talking about somebody's name, that would definitely be a string, okay? And it can't be a char, because char is only one character, so I have to go with string. Okay, so we're gonna save someone's name, so we're gonna put name1. Okay, and we're gonna put Bill in there. So anytime we have a string, we put double quotes around it to say that it's a string. And if we have a char, we put single quotes around it. Okay, if we're in it, it's called a char, C-H-A-R. Okay, so string name1. Okay, and then we can put comma. Whoops, let me put that outside of here to say that we have another one that's name2, and that's going to be Ted. Okay. You watch Bill and Ted movie? No, too long ago. Okay. So you could have put on separate lines. You could have put string name1 equals Bill semicolon, and then string name2 equals Ted semicolon. That would be fine. But if you know that they're both type string, if they have the same data type, you don't have to repeat the data type. You can put a comma and you can put the next variable, and it's going to assume that data type of the one that you had before. So if they have the same one, you don't need to repeat it. You can condense it in one line. You can if you want to. You don't need to. Okay, then on the next line, what we're going to do is we're going to print out. And I just want to show you if we wanted to print out name1, which would be Bill, right? And anytime you're printing out a variable, just to kind of review, you don't put quotes around it, because if you put quotes around it, then it's going to print actually name1 instead of what's in name1. So the way that you let C++ know, I don't want to print name1, I want to connect it to whatever's in the memory location of name1, you don't put quotes around it, and then it knows, look for that. Now, if you misspell name or you capitalize it differently, then it won't find it and you'll get a syntax error. So it has to match exactly whatever you caught it up there. And you can't put spaces in your variable name, so we can't say like name space 1. We have to push together. We can't start with a 1. We can use underscore if we want to, but typically we just push the words together and the numbers together. Okay, so name1, and then we're going to join it with a string that says and. Okay, so when we join in C++, we can put the arrows again, and then we can do and. But if we put and like this, it's going to push it right up against the word Bill. Okay, because it's going to say Bill but and is going to be pushed right up against Bill. Everybody with me? Okay, we're going to leave it go just so we can see what it looks like. Then we're going to join it again. So we're going to put the arrows with name2. Okay. So we're going to say Bill and Ted. And then I'd like to add another string. Whoops. So we'll put the arrows. I'd like to put an apostrophe S and then put excellent adventure. So it's a movie, if you're interested. All right. But, you know, looking at that, you might think, okay, that's okay, right? And then we kind of get used to the color coding of whatever editor you're using. So if you're using online GDB all the time, then you'll probably get used to strings are green. And if a string's not green, then they'll probably key you into like something is wrong. I didn't put the quotes where I needed to put them. And other editors have different colors. So whatever editor you're using, like if you're using C++ Shell, it looks a little different, or VS Code, you kind of get used to whatever you're using and you start to notice like, oh, I might have made a mistake. So let's hope that everything's fine. If we look at the color coding, everything looks good. So we'll go ahead and click run. Oh, I did not do, so it looks good, but I did not end it. So I either have to go with a semicolon here, or I have to put arrow, end L for end line. Because that's actually the end of my statement, and I don't have anything after that, I don't have to put end L, but some people like to in case they add something later, or in case whatever editor they're using sometimes prints extra information. You want that to go to another line. So sometimes I put end L at the end just so that all of that ends up on the next line. So it's really up to you, but a semicolon is fine. And then we'll say, okay, try that again. And then you notice the reason why we run and we have to test things is because we may think it looks okay. We assume it's okay, but we didn't actually run it and test it. And this is why I think it was a little confusing on the exercise I gave you for the inches to feet, because I actually had two different runs, and I had one with the data that I gave you, and then I changed the value and I ran it again. I try to have you run it multiple times, especially when you're working with numbers. This one, once you fix it, you don't have to run it multiple times because it's only going to print the same thing. But if you had numbers, changing the numbers and seeing it with different results is a good idea just to make sure that it works. For this, you have to run it at least once and say, that doesn't look good, right? I need to fix that. So you should never have output that looks like this, because if you're looking at your code, you always have to run it and test it, right? You can't just assume it works, because if I'm looking at that, I might think, that looks good, let's just turn it in, right? But that doesn't look good if you test it. So I just have to add a space here. And then I also notice that there's no space here as well. So I need a space on each side of the ant. And it has to be in the quotes, because if you have spaces outside the quotes, it does not matter in your actual output. You can put as many spaces, like for example, you can put spaces here if you want to, but it does not impact your actual output. If you want to, you can condense or you can put spaces. Some people like to have extra spaces. I think it takes extra time, but it also separates a bit if you want to. So really that's just your preference, but that does not affect your output. Affecting your output is what happens inside the quotes. Did everybody get that to display correctly? And then we know that that works, right? Okay, so if you want to save this, one nice thing about online GDB is it does have this ability to download your file, or you can just open up a text file and paste it in and save it with whatever name you want. I really didn't have pseudocode for this one because I really didn't have much to do. I was just printing something to the screen. I could have created a pseudocode for it, but you can just copy this. You can do, I recommend doing Control A on your code, because Control A makes sure you're not missing like a curly brace or something. Sometimes when you highlight, you forget to do a curly brace and then it doesn't work. So if you do Control A, if you click on it, Control A highlights everything, and then Control C or right click copy, and then you can paste it into here. And if you need an example of strings, you have it. There is a string preprocessor you can add, but the newer versions of C++, you don't need to. I mean, it's been a while since we need to do that, so you don't really need a preprocessor for strings. Okay, so I just pasted it in, then I can save it with whatever I want, and then you can use that. Now, if you save it as a TXT file, of course, it's not going to run. You have to paste it into like online GDB or something to make it run. If you save it, if you do the download, it'll save as a CPP file, which is a C++ file. And then you can actually just upload it right back to online GDB to run it. You don't have to like copy and paste it if you wanted to. So that's an option. But most of the time I do make you do pseudocode and output. So when you're doing like your exercises, you do need to paste it into a notepad anyways for that. So, but it's easy to copy it back out of for whatever you're using it for. So you can say string, maybe string practice or something like that. And I recommend that you have a folder for chapter 2. You're putting everything in it so that if you need to look at an example with strings, you can go back and look at this example. And if you don't need strings, then you don't need this example. All right. And you don't need to turn this into me. This is just practice. This is for you to have as an example. I want you to have many examples to work from so that when you're trying to do something, you know exactly what everything does. Okay, so everybody good with that? Okay. All right, so hopefully this is all starting to make sense. The more you do, the better it gets, right? So this time we're going to take out this. And this is not practice with strings, but I can leave my name and date on there. This one we're going to do division practice. Okay. And so we can kind of think of, we can open up another notepad file here. This one I can do pseudocode for. What I'm trying to do here is I'm trying to have a number of questions and then how many the person got right. And then I'm going to try to divide the number that they got right by how many questions to figure out what percentage they got. So I'm trying to figure out if they had a test and they got 9 out of 10, what would that be? Okay, so just a simple division problem. Okay, so we're going to have a number of questions. Okay, and then we're going to have number correct. Okay, and then we're going to divide, and we'll save this in the percentage. So we'll say, okay, we want a percentage. Remember that things that are decimals are called double in C++. So double percentage equals, we'll take the number that you got correct divided by the number of questions that you have. And then we want to print the percentage. Everybody good? And that's kind of what we want to type into C++ without semicolons and such. Okay, so I can kind of, you know, I can even put this over here, kind of remind myself what to do. Then go back over here, make sure I'm indented. Okay, so first I want to start with the number of questions. And we haven't learned about input yet. So next chapter we learned about input, which will help us to be able to ask the user how many questions they had. But right now we just have to type it in a variable. I know that sounds like, okay, now I need to change what's in the variable, but we're getting, this is like a stepping stone for taking us to input. So we're going to create a whole number variable that is called an integer, called int, data type in C++. And we're going to name the variable QUES, just for abbreviation, because I don't feel like typing out the word questions. Okay, so we can abbreviate it. You could call it Q if you wanted. It's really up to you as long as it relates. I just don't want you to call it A. It has to be something meaningful that relates to questions so that people aren't confused by your equations. Okay, and then we're going to put a number in there. I'm going to put the number of questions as 10, but you can put whatever number you want. How many questions were on the test? That's the number of test questions. And maybe you think like QUES isn't descriptive enough because it could be the number of questions you got right. It could be the number of questions you got wrong. It could be the total number of questions. So maybe you want to call it number or total questions or something. Okay. But it's up to you. That's fine. And then we're going to call the next one correct. Okay, so how many did you get correct? So we'll say we got 7. Now we know this is a 70, right? Because we can just do that math. Keep it pretty easy. But we want the computer to calculate it. We don't want to do the calculations. The only time you want to do the calculations is to double check it. But after you've double checked it, then you shouldn't always be calculating it in your head and manually putting in the answer. You should let C++ do the work for you. So we're teaching C++ how to do this. And so we have 2 whole numbers because you can't have a half of it. Well, sometimes you can have a half a question, right, I guess. But normally it's just a whole number, right? And then we're going to create an equation where we're going to divide those 2, right? And when we divide the 2, we need a place to store it. So you can either do it the division right in the printout when we want to print the answer for the percentage, or we can put it in a variable and then print it out. Really, it makes no difference. It's fine either way. So normally I like to step it through step by step so everybody can kind of see, okay, I divide it and I save it someplace, and then I use that value that's saved somewhere to print it, okay? And that definitely makes sense if you're going to use it multiple times, but I could see how you might say, I don't want to save it someplace just to print it. I could just do the division right from the printout, and that's fine too. So really, again, it's up to you. So this one's going to be a double because it's going to be a decimal number. It'll say like 0.7 for 70. Okay. So we're going to take the number of questions you got right, which is correct, divided by the number of questions, which was, how do I know how many questions I got? What variable is that? Thank you. QUES, good. Right. Actually, I need to put a variable name here. Sorry. So let's put percentage, or you can just call it percent. So you need to come up with a variable name that you're going to store your division value, the result from your division into. And this is actually going to create a problem. We'll talk about it in just a sec. But we'll move on and we'll print it to see what it comes up with. So it will do the division. It'll take how many correct divided by how many questions. You need to make sure you use the same names that you have here down here. Is everybody following so far? And if you don't like it all up against each other, you're welcome to put spaces. That really is just up to you. Okay, and then I need to do the next part. I need to print the percentage. Okay, everybody good? Okay, so on the next line, before I run it, I want to print it. So in C++, we print by doing cout. Okay, and then instead of just printing the percentage, I like to put a label with what I'm printing. So I'd like to actually say the word percentage, and then I'd like to print the percentage. So here I'd like to actually say percentage, and I want it to write it how I want displayed. So I want like a capital P there. It doesn't have to match the variable you have here because this is just a string that is showing as a label for the output. So write it the way you want the person to see it when they're viewing your output. And then to get the actual percentage, I have to use the variable that I have here, right? Which is percentage, right? And I have to write it the same capitalization, the same spelling. And so then I put here, because C++ is just going to pull whatever in there. And then I have to put a semicolon at the end to say I'm finished, or I have to put an end line. If I want to put end L, I can do that. It's really up to you on that one. If you were going to have multiple couts, then I would put end L, but when you just have one, it's fine. Okay, and then I have to see if it's correct, right? So once I print it, because if I just do the calculation and run it, I won't know what the answer is because it calculated, but it didn't print it. So once I have the printout, then I can test it to see if it's working, right? So go ahead and run it and see if it's working. And it tells me 0. That's not good. Okay. 7 out of 10 usually isn't 0. But in C++ it is because you did integer division. So here you see that you have 2 integers, which means 2 whole numbers. So up there I have an int and an int. And if I have 2 ints, then I get an int as a result. And so the int doesn't get rounded, it just gets chopped. And so even though it should be 0.7, it just chops off the 0.7 and gives you 0. And so you have to be very careful of integer division. Sometimes it's handy, and we'll talk about today how it can be useful, but other times it causes problems in your equations because that's not what I want. I don't want it to chop it. And so I need one of those to be a decimal in order for it to work. And there is a way to do like a static hash we'll talk about later, but for right now, just to keep it nice and simple, if I just make one of those data types not be an integer and be a decimal, then it'll work. So if I make it a float or I make it a double, then I can force it to work. Does that make sense to everybody? So if I just change one of these, it doesn't matter which one you change. Or if I change both of them, then you can actually cause it to work. So if you have one decimal number in your division, you will get a decimal answer. And so then you should get 0.7. Okay. Now we've only been working with 2 numbers at a time. That's why I'm not multiplying it by 100. But I could have another variable that I had, on the next line that takes that percentage and multiplies it times 100. Or I could just take the percentage in the output and multiply it times 100. Then it would say, 70 instead of saying 0.7. But, you can just 0.7 is fine too. Everybody with me? So you can do equations in your output. So what I was saying is if you wanted to, you could just actually multiply it times 100 right here. Okay. And then it would say 70. But then you might want to say, you could put a percent sign after it. If you want a percent sign, you just add. So you can get really fancy with it and play with that. You can put percent. That look better. But now what I was saying before is, okay, I have this code, and then normally for your exercise, I would say, okay, or for your assignment, I want you to put the code in here so you have it. And then down below, I want you to put the output so that you can prove that you're testing it. So you would just put, okay, this is the output down here. Okay, whoops, it didn't copy that. It's like stuck on that. Okay. Why is it not copying that? Okay. Then I want you to try to run it again. So usually, just for testing purposes, okay, maybe I got lucky because the first time, remember we had that problem with the division? And let's say that I got a 0 correct, and then actually 0 was the answer, you would say, oh, it works. But then when you put 7 in there, it didn't work because it would say 0 again. So try with different numbers. Like this one actually should be 0 because you didn't do any of the problems, or you didn't get any of them correct. So if you happen to just put a number that works out to be the answer, but then other numbers don't work, then that's why you want to test it, because maybe you lucked out and the one number that you tried worked, but other numbers don't, especially when we get to like decision making, when we get to conditionals. We might try one condition and it might work, but maybe the rest of our conditions don't work because we didn't have like an equal sign where we needed it. So we need to test multiple times, not just one time and say, oh, okay, it works. So in this example, I was just saying, okay, I tested it with multiple numbers, getting different percentages. I do not know why this is not copying for me. Okay, maybe if I do like this. Okay, so that's why I had that. I had multiple, because I want you to show me you ran it multiple times with different input. And it doesn't matter to me what you change the numbers to be. You could change the number of questions. So you could say, okay, I have 100 questions, or I have 50 questions. And how many did you get correct? Okay. And that should be pretty easy, but maybe if we change to 50 and you got 28 out of 50, that's not great. Okay, so you can change the number of questions, you can change the number that you got right, and see if your percentage makes sense with what you have. And then you know your program's working. Now, eventually this will become more interesting because we'll take input from the user. How many questions do you have and how many did you get correct? And then it would automatically update according to what they inputted. But right now you have to go into the code and change the numbers. So we won't have to do that after the next chapter. But for now, that's how we test it. Everybody with me? Okay, does it work? So go ahead and save this. You should have the pseudocode and the code. Go ahead and save that so you have that as an example. So we can save as, maybe call this percentages or percentage, test percentage, whatever makes sense to you that you're going to know what that is when you come back to it as an example, so that when you are trying to do your assignment or you're trying to do your checkpoint, you know which examples would be helpful to do your task. So just name it whatever you think would be helpful. Anybody have any questions? Okay. Okay, perfect. Okay, I want to get a little more challenging, but everybody's okay so far. Okay, let's get a little more challenging. Okay, so this is going to be a longer program, so some of you might type faster than others. If you don't get the whole thing typed in, I can print it off later for you so you have it. Okay, so this one, I'll start again here. Actually, I'm going to get a new tab here. Say pseudocode. Okay, so the goal here is we're going to try to have a number of cups, okay? And then we're going to try to figure out how many pints that equates to, quarts, and gallons. Okay, and then we're going to print off this information. Okay, so we have this total number of cups that we're starting with, and then how many pints, quarts, and gallons do we have that equates to? Okay, so we need to have a number of cups. Okay, so we'll say cups. So we're going to have a number of cups there. Okay, then we're going to have cups. How many cups are in a pint? Okay, and we're going to create some variables at the top that store this information for us. But we can also just put the number in our equation. That works too. So I'm going to say that pints equals, I'm going to say the number of cups that you have divided by 2, because that's how many cups are in a pint. And then quarts is going to be the number of cups divided by 4. And then gallons is going to be the number of cups divided by 16. Okay. Now, if you leave pints, quarts, and gallons as an int, then it'll only give you the whole number version of what it is. But if you wanted to give you the decimal, like how many cups, what fraction of cups are left over, then you would make these all doubles. So it really depends on what you're looking for. So when you're thinking about it, and that's one good thing about the pseudocode is thinking about what type of answer you're looking for. Are you looking for a decimal for all of those? Are you looking for a whole number? Because if you're looking for a whole number, then you want to go with int. If you're looking for a decimal, which would give you a fraction of how many cups are left over, then you would go with double. So it really just depends on what you're looking for. So this is good to think about before you actually code it. Oops. Okay, and then we want to print the answer. So then we want to print how many pints. Actually, let's print how many cups, because we don't know how many we started with unless we look at our code. Let's print how many pints, print how many quarts, and how many gallons. Okay. Okay. Now, we can go over here to the code now. And we can go up to the top. And this one, we can say something about convert cups to pints, quarts, and gallons. And we can erase what we have in there. Okay. And then we want to start just like we have. We want to put int cups and how many cups. And this can be whatever number you want to start with. We can put 10 and then we can change it later. This will be good again later when we have input from the user. We can put whatever number the user wants, but right now we have to go back and change that number. But 10 is a good starting number. We'll try that to start off. Then we're going to put, it's up to you. See what you could do, and you have to decide what works for you. You can declare all your variables at the top. You can say pints, quarts, and gallons all in one line like that, and telling C++ that you're going to have a pints, quarts, and gallons variable, and they're all going to be decimals. They're all going to be doubles. Or before, you know how I have it up here with the equations in the pseudocode, you can say before each variable, before you actually put the value into it, you can just say double pints equals like that, if that works for you. But if you do it like this, then when you do your equation, you'll say pints instead of double pints. Pints equals cups divided by 2. Okay? Versus putting double here, because either way you're kind of repeating, because you're repeating all these names here, but you're not having to repeat double before each one. So it's really a matter of preference. It's what you like. And then you can say quarts, and I can change it in just a second to show you what I'm talking about. Equals cups divided by 4. And then gallons equals cups divided by 16. So it's the same really that you have over here with the semicolon. So this declares all of them. And then this creates all my equations. And then I have to print everything out. Okay? All right, so then I would have my printouts. I would start with my cups. And I always like to put like the colon there and then put my variable. And the variable has to match whatever name you use up here. But, if you want to say cups equals, however you want to print that off, you can put it in a sentence form, the number of cups are. But but I usually just put it like that and then C out. And then you want to do all of the different things that you have. So go through all your variables, just make sure you use the same variables. And then once you get that, go ahead and run it and see if it makes sense with the number that you have with 10. Now, I have not been putting end lines. So this is good for testing purposes. I'm doing that because I want to show you something. Sometimes you may think, okay, this looks good, and then you don't run it and it doesn't look good. This is why it's very important to test. Because if I were just glancing this, I would say, oh, that looks good, and I would just be done with it. But if I run it, I will notice that that doesn't look good. So it's very, very, very important that you run it, because just glancing at that does look like it would be okay. But when I run it, I will notice that that output does not look good. That looks very bad. Okay. So then hopefully that tells you, hopefully you're getting to the point where you can look at that output and you know exactly what's wrong. So when you run it, you can say to yourself, oh, that's not good. Why is everything on one line? I don't have any end lines on the end of my cout statements. So I need to go ahead and add some end lines to make it look better. I didn't need it when it was just one line, but now that I have multiple lines, I'm going to go ahead and add end L at the end of each one. And just copy this and see if that helps fix my output. And I could add it. The last one is optional because you don't have anything after it. So, okay, now I can read it better to actually check my answer. So first I need to format it so I can read it. And then I can check it to see if it makes sense. So if I had 10 cups, would that be 5 pints? Well, there's 2 pints in a cup, so that makes sense. And then would I have 2 quarts? Well, there's 4 quarts in a cup, so that makes sense. It does not give you the decimal leftover amount because, oh, it should, right? Oh, it doesn't, because cups is an int. So it doesn't matter if you have double for all those, right? Because if cups is an int, then you're going to get an int anyway. So really, if you're looking at that and you wanted the decimal, even though I made them all doubles, I'm not getting the decimal because I'm dividing 2 ints. So I have that integer problem again. So it doesn't make sense for me to have these be doubles up here and then divide an int by an int, because then I'm going to get an int. So if I'm going to do that, I might as well save space and make this an int up here, because a double is twice the size of an int, so it takes up twice as much room. So it's kind of like wasted space, because if you're going to do that, then why have it be a double? So either I would fix it to be an int and just go with the int answer if you think that looks nice. Like if you don't want it to say 2 point something for quarts, then I would just go with int up there, and then that would work and that would save space, because there's no point in having a double if you're dividing ints. But if you want to fix it and you do want it to give you the decimal answer, then you need to fix this, or you can actually fix this. Like let's say you don't want to enter a decimal here for cups. Like you don't want people to enter a decimal number here for cups. Then you can make it 2.0 here instead of making cups. So you have 2 choices. You can fix the first number or the second number. So the first number would mean that you make this a double. The second number would mean you just make this 0.0. Or you can fix both. Either way is fine. It's just that if you make the cups the decimal, then people can enter a decimal number of cups, and you might not want that. It depends on what you want. It depends on what your goal is. So if you are okay with them entering 10.5 cups, then make that a double, that's fine. But if you're like, no, it has to be a whole number, then don't make it a decimal number. Make the other number a decimal number. And then that should fix my answer. So because I allowed for these all to be doubles, then that should fix my answer. But I want you to know the difference, because just putting double for all these variables does not give you a double if you're doing integer division. It does not make your division do double division. Only the 2 numbers in the division are the numbers that affect the answer. So if you have a division with 2 numbers and they're both whole numbers, it doesn't matter what the variable type is you're saving it back into, because if those 2 numbers are integers, you're going to get an integer, and then it'll save it back into a double, and it'll waste space, but you're not getting a double because those 2 numbers are integers. So the 2 numbers in the division have to be fixed in order for you to get that decimal. Now, if you save it back into an int, then it's going to chop it again. But if you save it into a double and one of your numbers in your division is a double, then you'll get the decimal. Make sense to everybody? And so you're going to see people's code look different because this is the point where you're going to make decisions, and these are preference decisions. I mean, there's always decisions like, okay, do I put spaces here or not put spaces there? That's a preference, right? Do I add comments in there that says what each line does, things like that? But I was telling you before, you could have done this with each line. Right as you're putting a value into it, you could have actually declared it, and then you wouldn't need that line up there. If you think that looks better, it's really up to you. What makes sense to you? Do you like to declare all your variables and then put values into them later with the equations? Or do you want to declare them right when you put the value in with the equation? That's really a preference, but you can't do both. You can't have that line on there and do this. If you try to do that, it's going to tell you that they're already declared and you're redeclaring it. And you can't declare a variable twice. So if you ever see it saying something about that, that means you already told C++ that you have a variable called pints and it's a double, and you can't tell it again that pints is a double. You can use pints as many times as you want throughout your code, but you can't keep saying that that variable is a double. You can only say it one time, and the data type of a variable can't change. Like you can't have a variable that's a double and then later change that variable type to an int. The variable type stays throughout the program. You can't change data types of variable. You can do casting, we'll talk about later, but you can't go and say that that variable with declaration is a different data type. Does that make sense, everybody? Okay, so I can't do that twice. I have to take that off of there. So this is where you start making decisions as to what makes sense to you. The other thing is, you might see, I don't want this to take up 4 lines with these different cout statements, and I don't want to have to keep saying cout. So another preference thing that you can do, we talked about this before, is you can condense this. You can say, okay, well, I don't need to do end line. I can put \n here. I'm kind of move this over here. Okay, I can take this, and this is up to you. And you can put end line, which is a little bit less code, \n, and you can break at the, if you want to take it to the next line, but it won't be on the next line in your code. If you're just off the screen, you can take it to the next line. So it can look all different ways, and it still works. Well, we have to test it to make sure it still works, but this really doesn't need this, so I can just leave that. And maybe I can move this up with the previous line. You can break it at the arrows though, and then normally you kind of indent the arrows together, but you don't have to. That doesn't show up in your output. That's just how you want your code to look. The way that C++ knows this should be on a separate line is either end L or the \n. Like you hitting enter in your actual code doesn't show up in your output. It doesn't matter if you do separate cout statements or if you break it at the arrows and you bring it to the next line, because that's just a preference thing. You're going off the page or off your monitor. And I wouldn't be off my monitor if I didn't have the pseudocode over here, so I could probably just continue the whole way out. But I just kind of broke it here because I think it looks nicer. But again, that's a preference thing. It gives you the same output. So really, both of those work. The only thing that bothers me, I talked to y'all about this before, is this is a pet peeve of mine. That drives me nuts. No, don't do that. But otherwise, like things should be indented inside of the method that they're, I shouldn't say method, that's Java, the function that they're in, or whatever block of code they're in. So make sure that like if things are at the same level, that they're indented all together. Like this is all at the same level here. When we start talking about like doing conditional decisions, we will put whatever's inside that condition like indented. And so as we get more complicated and we put things inside of things, if your indentation's all over the place, that's what drives people crazy. It's like, I can't tell what's inside of what because everything is at the same level. Now I moved that arrow over with the cout because it belongs to the previous statement. So it kind of tells you, hey, it goes with the previous statement. So that's okay. But having it at all different spaces is kind of hard to read. So just make sure you're not doing that. But otherwise, all those other preferences are up to you. Everybody good? Does this work? Okay. So you can go ahead and copy this code. and paste it into your notepad. And I want to copy the output. Let me see if I can get this next time. You're not turning this into me, so you don't really need to copy the output if you don't want to. But if you want to remind yourself what it looked like, if you're looking back at it as an example, it might be good to have. Let's change the number of cups and make sure it works for testing purposes. So we tried 10 cups. Let's try something bigger because we know that the gallons, we didn't even get a gallon with 10 cups. So let's try like 50 and see what happens. Okay. And then I want you to look at the answers and make sure it makes sense. So with the numbers we have for how many pints or cups are in a pint, how many quarts are in a cups are in a quart, and how many cups are in a gallon. Make sure your answer makes sense. And then if it's okay, then go ahead and copy that and paste it. So we need to try it at least twice and make sure that different numbers are working. Okay? Everybody doing good? Okay. So then we would go ahead and save this. So we have this for later. So go ahead and save this text file. And something that makes sense to you. So cups conversion maybe? Something that you would know what it is. And then that way you have many examples to work from. So this one has more equations in it. Okay. All right, let's do another one together. So let's go back here. And I want to get another new text file here. And this time what I'm going to do is I'm going to figure out, I have a total number of seconds. So we're going to have a seconds variable. Okay. And we're going to figure out how many minutes, hours, and days that would equate to. Okay. So we are going to say, okay, we have the number of minutes. This one we're going to do int for minutes. Okay, I'll just call it min equals. Then we're going to take the number of seconds. You could just call it sec if you want. Okay, we're going to call it sec divided by how many seconds are in a minute. So there should be 60, right? And then we're going to do the number of hours that would be. So we take the number of seconds divided by how many seconds are in an hour, which is 3,600. And then we're going to do how many seconds are in a day. So we'll take the number of seconds divided by 86,400. Okay. Pretty good. And then we're just going to print how many seconds we have, how many minutes we have, how many hours, and how many days. Kind of like we just did for this one. And then once we do that, we're going to figure out how many remaining seconds we have. So we'll use that modulus one. So we'll do this first, and then we'll kind of go from there. So let's clear this out because we're starting from scratch here. Move this over a bit. Okay, so I'm not converting cups to pints, quarts, and gallons anymore. So I'm converting seconds to minutes, hours, and days. Okay. I'm going to try something different for this one, and you can tell me if you like it or don't like it. We talked about what a constant is. A constant is a variable that doesn't change. So we're going to create a constant variable. We're going to say COSC, and we're going to say int. And how many seconds are in a minute? We're going to put that up here. Seconds per minute. Okay, and we're going to say equals 60. Okay, now this is just a variable name, and because it's a constant, it gets all capital letters, and you put an underscore between each word. And so it puts COST means it's not going to change. So if I try to change the seconds per minute later in my program to be something else, put a different value in there, it would tell me I can't do that. Okay, so that stops someone from changing it. Then we're going to do the same thing for how many are in an hour. So put COST seconds per hour. How many seconds are in an hour should be 3,600. And then how many seconds are in a day per day? And this is that 86,400. Don't put commas in your number though. Okay. And then I need a seconds variable. Whoops, on the next line. I'm going to have a seconds variable. Now the seconds variable, I'm not going to make as a constant because if I wanted to change that later, I could. I don't have any reason to make that a constant. That's a number that I do possibly want to be able to change later. So we'll put, 10,000 just as a starting number. And we'll change that later. Okay, so these are our values so that we know how many seconds are in a minute, hour, and a day. Okay, then we're going to do our equations to figure out how many minutes that would be, how many hours, how many days. So we can create our variables as we go, or we can do them at the top. So really, again, that's up to you. So we can say int minutes equals, and we can do the number of seconds. Again, I can abbreviate this if you don't want to keep typing seconds. I can do second divided by seconds. Now, this is pretty cool. When you start typing it, do you notice it comes up? You can just double click on it. Oops, put that in the wrong place. Okay. And then we can do the number of hours. Equals the seconds divided by seconds per day, or seconds per hour. And then the number of days equals the number of seconds divided by the seconds per day. I keep putting it in the wrong spot. It keeps coming back. I think I erased my number up there. I don't know how. Okay. And then some people like to, it's completely up to you, but this could be declare variables, calculations, output. Everybody okay so far? Is anyone confused? You might still be typing, but are you confused? Is everybody okay? All right. Now we want to do our COs, and we want to do how many seconds first of all. So the number of seconds we start with would be our seconds variable. Now again, this is up to you. Do you want to do it as one line? Do you want to do like an n line here? How you want to do it, if you want to condense it, is up to you. I think sometimes when you're first starting off doing them separate lines, maybe makes more sense. But if you want to condense it, you can. So this would be how many minutes, which would be your minutes variable. Make sure that when you do it, you use the right abbreviation that you used here. Like I used hours, not hour. Make sure you use the right one. Okay. And then just keep going with that. Try to use your variables. You'll know when you try to run it if you made a mistake with the variable name. Okay, and then go ahead and run it once you get it and see if it gives you the right thing. I made a mistake somewhere. Oh, I somehow erased my, when I was doing it, erased my parentheses up there. I think it highlighted it and I was typing over top of it somehow. So that should work now. Okay, so did you get the same answer I got? Double checking that answer. 10,000 is not enough to make a day because it takes 86,000. So this is where you need to check it once and then check it with multiple values to see if it's working. Okay, that looks like it works, but I didn't even test my how many seconds per day. So I need a value that's big enough to equal a day. So I put 100,000 in there, which should give me 1 day. It redoes it for each one though. So you notice it tells you how many minutes that is, how many hours, and how many days, but it doesn't subtract from the previous one. So it's not like, okay, this is how many days, and this is how many hours will be left over. So you can see that it says 27 hours, for example, but that would be more than a day. So it's telling you how much it equates to for each increment, but it's not telling you like, okay, 1 day, how many hours are left over and how many minutes are left over if you're thinking of it that way. So we can switch the program once everyone's okay with this to do that in case you're, you wanted to do that as an outcome. But just before we do that, does this make sense? Anybody confused on what we're doing? Okay, so if we want to switch our program, we have to do a little bit of work. So it's pretty much set up, but I kind of want to switch the order in which I put things. So I think it's fine this way for the way it is now, but if I wanted to put how many days, how many hours, and how many minutes, and then how many seconds are left over, I want to switch the order of my output. So what's the first thing I'm going to do? I'm going to switch the order of my output. So I want the days to actually come first. So I can leave the seconds alone. So how many total seconds do you have? And then I just want to switch this days to go up before at the top after the total seconds. And then I want the hours to come next. So I just want to rearrange these. And I'm sorry if you did it with a \n because it might make a little more work. I want the days, then the hours, then the minutes. So I'm just kind of rearranging the order a bit so it looks like that. I'm trying to set it up for it. It'd be nice if it told me that it was 1 day, but it wouldn't tell me 27 hours because that would be a day. So it should tell me that there's 3 hours left once I get a day. And then whatever minutes are left over from that. Would that'd be cool, right? I'm super excited. Okay. So you have to rearrange that to make it look nice because otherwise it looks strange to start with the minutes and then go down the other way. So get that in the right order, okay? Now, the same thing, I kind of want to rearrange the order of my equations here. I want to put the days one first, and then I want to put the hours one second, and you'll see why in just a second. So I want to rearrange my equations. I can leave these variables alone, but I want to rearrange these so it goes days, hours, and minutes. So it made sense before to do it that way, but for this one, I'm going to put it in the opposite order. So I'm rearranging my equations. Did everybody get your equations rearranged? Okay. So now this one is okay. I want to take how many seconds are in a day because that's going to be our first one. So that's actually the right answer and that's fine. But then I need to figure out how much is remaining from that. Okay. So in the next line, I need to figure out remaining. Okay. So remaining is going to be something, I'm going to put int remaining. How many is left? Okay. So I'm going to say int remaining equals the number of seconds, which I put SEC, whatever you put for seconds. And then you're going to put modulus, this one always throws everybody off, how many seconds are in a day. And then I want to talk about that for a second. You want to put a comment, determine remaining seconds after dividing days. I can take this. I'm not diving, dividing. Okay, so after you divide the number of seconds per day here, then you're going to have something left over. So this is going to determine how much is left over. So remember that modulus means to divide it and then get the remainder. Is everybody following? Okay, I need the remainder to then figure out how many hours I would have. Okay, so instead of taking the number of total seconds that I have, because I already took out how many days I had, I need to take out and use the remainder. I'm using remaining here instead of total seconds. But I'm still leaving the int hours the same. Are y'all with me? Okay, perfect. And then what I want to do is I want to add on here, I want to do remaining again equals, and this time I want to do remaining instead of the total seconds, modulus seconds per hour. And I want to give you a second to process that. And I'm going to put a little comment here. Remaining. However you want to explain that to yourself if you're trying to figure out what that's doing. Now, you notice up here that I put int remaining, but down here I didn't put int remaining. Does anybody know why I didn't put int remaining again?
You already clarified it, isn't it?
Yes, perfect. I already told C++ it's an int, and if I tell it again, it'll get upset. So you tell it the first time, and then you don't tell it again. So it's like, I already know that memory location. I'm just using it. And every time you say remaining equals, you're just replacing the value you had in there before. So you don't need to, once you've figured out and moved on to the next increment, you can then replace what's in remaining for the next increment. And so you can keep reusing that same variable. And so it's a little tricky because first we're pulling out the number of days because that's the largest. You have to start with the largest increment because if we pulled out the number of minutes, then we wouldn't have any left for days, right? Pull out the days, then whatever seconds we have left from after we divided days, then we'll determine how many hours that is, right? And then if we divide by the hours, we find out what's left, then we can figure out how many minutes that is. So everybody kind of understand the process? Okay. So it's kind of like you're doing this all the time. It's just you're not really like trying to teach C++ how to do it. You may do this in your head if I asked you, this is the number of seconds. How many days, hours, and minutes? You'd probably be like, oh, it's this, but you don't necessarily think about the process in which you had to do that. How did you come to that answer? But this is what we're doing, and we're having to break it down as if we're teaching someone, but now we have to put it in syntax, which is even more difficult. So we're having to break it down step by step. So now we have the number of hours, right? So here, instead of doing seconds, we will do remaining again, because we never want to start back with the total number of seconds, because that would give us way too many. We always want to use the remaining, what was left. So we just figured out remaining here when we divided by the hours. So we need to use that here for the number of seconds to figure out how many seconds are in a minute. But then we need to figure out how many are left as well once we divide it. So then I need to do the same kind of thing. After, I need to do the remaining again, equals remaining modulus seconds per minute. Okay. I know I hit, okay. Hopefully I didn't hit an extra one somewhere. I wasn't on the right line. Okay. And then this would be after dividing minute. Okay. Now, whatever is remaining is the number of seconds that's left. So at the very end, I could say something like see out how many seconds, like something like remaining seconds. And then that would be my remaining variable. And this might take a little bit for you to look at and kind of study. This is a more difficult program. So I know we're at the end of our time here. So we'll start again with this on Wednesday, but take some time to look at it. So does it work? Does it look like, okay, you shouldn't have anything that is large enough for it to go to the next, like I shouldn't have 27 hours because that would have been large enough to give me a day. So I have 3 hours, so that looks good. I remember that I had 27, so now the 3 went down to the hours. And then I shouldn't have 60 minutes or more because then that would mean that it should be another hour. So you shouldn't have a number that is big enough to be the next increment. So just double check that. and then how many remaining seconds. So you can double check, you can use a calculator to double check or kind of check in your head to make sure it makes sense. And if you change this number at the top to be a different number, like let's say I go back to the 10,000, does the number that it's giving you make sense? Like I don't have any days now because it's not large enough to be days. So this is where I would test probably even more than 2 times to make sure it works, to see if your answer makes sense. So try a number of different seconds. So what I need you to do is kind of just study this program and see if it makes sense to you. And then we can go over it again.